sampling. I'll start today with a overview of the previous training, which was how to actually submit to one data gateway, which is our product that the NG911 enterprise solution runs on. And we just kind of wanted to do that to get you started. So you can start submitting data to some of those single layer validations. Oops, sorry about that. One moment. Everything cut out for a second. All right, let me get back to the presentation. There we go. All right, so let's go ahead and get started. Just as a review, One Data Gateway is the product that the Arkansas Public Safety Enterprise Solution runs on. It is essentially a way to share data between external users and internal users. So data contributors such as yourselves and the Arkansas State Office. We can use validations in the portal so that you can ensure that your data is meeting data quality standards over time. And you can see the quality of your data as it comes in and is submitted against those validations over time. So One Data Gateway, the enterprise solution, hosts a number of different validations that you can run different data layers through. Just a quick animation of what that looks like. So we have the contributors, y'all, as well as the Arkansas database and Arkansas state users on the other side of this portal. You're going to be submitting data to various validations. And the validations will process your data and gather statistics. It'll identify if there's any non-conformances in your data. It will also eventually, once you go through change detection, you can have that data submit to the central database. So change detection is one of those things that we'll cover today, and that's how we're going to ensure that only changes to your data are actually going to be submitted to that central database. So it takes actually a lot less time to process and submit. So with that, one second, whoops. I'm going to quickly sign in as my user account. You should have access to this portal. If you don't, you do need to contact, I believe, Jonathan Duran at Arkansas. He can help contact us here at One Spatial, and we can make sure that you're set up with an account. Previously, you've had access to these different validations. So essential geometry, essential network checks for road center lines, some of the single layer validations, such as NINA attribute validations. And so you've seen these different validations, and hopefully you've been submitting some data against them. This is what the initial process that we have envisioned you using the enterprise solution for. So that data validation. So you're maintaining your own data, you're submitting it to those data validations, and you're receiving information back. So once your data starts meeting basic standards for those data validations, you can start submitting against our change detection sessions. So I'll go over what that looks like in just a bit. But essentially, change detection is going to take your data submissions, compare it to a previous submission that is stored in the state repository, and then those changes are utilized to update the central state repository at Arkansas. So that's the second method that we can do within the enterprise solution. And so you've been able to do the first part. Now we'll be able to run change detection. I also want to point out part of this presentation is covering cross-feature validations. Those are considered data validations, but they're going to be validations on multiple layers. So maybe you're running site structure address points and road center lines, and you need to do a validation against both of them. That's going to be a data validation, but we also have change detection for each one of those layers. Just a review of our overall workflow, and this will continue for these other assignments that you'll see within the portal. We want to make sure that we are preparing our data. So you want to update that data in a GIS software. If you've completed the essential geometry checks, the NINA attribute validations, etc., on those single layers, making sure that you're addressing any of those issues that are found with a markup. So if there's a markup point saying that there's an issue with your NINA Global Unique ID, that's going to be an update that I would want to make in a GIS software prior to submitting to the portal. It's also recommended to reproject your data to WGS 84. Now, later on, I'll mention that we do have some requirements for WGS 84 later down. In change detection, we require WGS 84. So we recommend kind of starting off reprojecting your data before doing these essential checks or the NINA attribute validations so that it's already ready when you get to change detection. We also want to take our file geodatabases and compress them into zip files. So when you submit data to the portal, you don't want a folder and uploading a folder. Otherwise, it's just going to grab the very first file within that folder. In a file geodatabase, it's incomplete without all the other files within that folder. So we want to take that file geodatabase folder, zip it up into a single file so that we can submit that to the portal. Let's see here. Next up, once we've got our data ready, we will then want to log into the portal and choose an assignment that we're going to be submitting that data to. So in the portal, we're going to upload our data to the assignment, map our schema, run the submission, and then finally obtain our results. And once you have your results, we can then bring that output into a GIS viewer and then make any of those updates as needed. So if it's a markup and we can see, oh, here's where we need to mark up our data, we can, or not just mark up our data, but where we can address some issues identified by those markups, we can make those updates and then get that data ready to resubmit through the process. So we can continue this workflow until we meet those conformance requirements identified in the validations. And as soon as that reaches a acceptable level, we can then move on to another validation or move on to the next assignment to run our data against. So quick review of each of these steps with data prep. Again, recommendation to reproject your data into WGS 84. That's the EPSG 4326. And then we want to make sure that we're finishing our data up by saving it in a file geodatabase. So if you're looking at your file geodatabase in a file explorer window, you would see that it looks just like a folder. I use 7-zip, but if you use some other compression, some other way to zip up your data, you can use that method. But I simply use 7-zip and then I add to a zipped folder. That gdb.zip is going to be the file that I will actually submit to the portal. So once our data is prepped and it's ready to submit, we can then get started with the portal. So this is where I'm just going to switch over to show you. I'm going to choose an assignment here in the portal. So maybe I want to choose my NINA attributes. Here I can see my previous submission. And I can go down here and I can start a new submission. So when we start a new submission, it's a stepped process. You're going to upload that data. You're going to configure your schema mapping. Once you're done with the mapping, you can go ahead and save it if you want. Or if you've previously saved it, you can apply uh, those saved mappings. And then you can hit the continue button to start the process submission. So process submission will pick up automatically and will start running. And at that point, you can kind of leave it and let it run. And in a single layer validation, such as the essential geometry checks or the NINA attribute checks, uh, the process submission will continue until it finishes. You'll see in change detection that does require a little bit of interaction because we have safety gates that we'll introduce into change detection. But most part, process submission will take off and it'll continue. There are ways to automate it so it goes all the way to submission results without having any interaction on your part. But I'm a nervous Nelly personally. I like to kind of control and be very interactive with my data. So I typically will progress it by hitting the continue button myself. Finally, you have those submission results. That's where we're actually going to be able to download our output. So usually those are spatial reports, and that's where our markup points can be found. Or for some cases, it might be creating a markup area or a markup table record, or even a markup line. But we can obtain those on the submission results page. Now, once we have our submission results, that's where we can go and do some results analysis. So I mentioned we can download our outputs. So again, once you get to that submission results, you can go to the submission data at the top right of the screen and click output to download those spatial reports. We can then bring our spatial report into our GIS viewer. You want to add your original data that you submitted with those results, because those results are just going to have information about the submitted data rather than have the original data as part of those markup results. The markups essentially are just representing any non-conforming data. So here it looks like I've got some road center lines that have markup points on them. So those little red dots, little red points, those are my markups and they're markup points. And they're essentially just saying there's some issues with my road center lines in this data set. Now, not every markup might be a true non-conforming object. For example, if I have stacked address points because I have those address points representing an apartment building or a condo building, if those address points are stacked, in essential geometry checks, oftentimes they're flagged as duplicate objects. That's where, after I get these markups, I can actually do exception handling. So the exception handling process, you've submitted your data for validation, you're reviewing your spatial reports, and you see this has been marked up as a duplicate address point. That's not true. It's an apartment building. So instead of saying continue to mark it up and flag it as a non-conformance, we're going to create it as an exception. So we're going to change the exception field in the markup data store. And we're going to identify that as this is an exception. And then we will resubmit our data to that same assignment, this time with that markup table with those markups marked as exceptions. So essentially, you're going to start an editing session. In that exception field, just type in the reason for an exception, save those edits, zip those markup results back up, and then we're going to return to that portal and rerun the submission. This time, uploading our original submitted data and our markup file geodatabase that has also been zipped up, with those markups actually having those exceptions being flagged. Now, just a quick reminder, when you are adding new exceptions, when you get to the configure mapping step, You do want to make sure that you're mapping both the submitted data as well as the new exceptions. You can just switch the data set at the top left of configure mapping from one data gateway submitted data to new exceptions, and then just check to make sure that the configure mapping picks up those new exceptions and maps them correctly. So just some quick FAQs about exception handling. So what sort of data can be submitted as an exception? Those exceptions should be based on that spatial report output. So if you see that a markup point should be flagged as an exception, change the exception field for that markup point and then save it. So you're essentially going to be resubmitting the markup point. Markup area, markup line, markup point, markup table, all of those could potentially have exceptions depending on the output that you received from that validation. So just be aware if you know that there's an area that should be flagged as an exception or a polygon, you might want to use a markup area if that is the output that you received from that validation. Do you need to upload new exceptions every time you run a submission? Those exceptions is a optional data set. So if I take a quick peek over here, you can see there's a required column. My submitted data, I have to upload a data set for submitted data. There's not a check mark for required for new exceptions. It's an optional data set. So you do not have to upload new exceptions every time you run a submission. Only when you have new exceptions to add. And then how do you remove an exception? You can actually reset that exception value for the features markup, reset it to null, and then you do need to re-upload those new exceptions so that it deletes or removes that exception from the rest of the data. So it understands this is no longer an exception. So that was a very quick overview of what we covered in the last training. Now I want to cover some cross-feature validations. So cross-feature validations include any validation that has more than one layer that needs to be submitted. So for example, we have some legacy multiple layer validations where we're comparing like an MSAG table to road center lines. We also have cross-feature validations for some of our NINA layers, like checking boundary-to-boundary relationships between PSAP boundary and the fire emergency service zone or emergency service boundary. So I'll go over each of those. I'll also go into detail about what is being checked during each of those cross-feature validations so that you have an idea of what each one's looking for. And again, I do want to point out in the assignment, there are rule catalogs for these validations. So if you are looking at submitting data and you want to go and check, well, what's actually happening, just remember that information field, the information tab, that should have a rule catalog that you can download and then take a look at and see, oh, this is a great, well, this is for our NINA attribute catalog, but this is essentially what it looks like. There'll be some background, some schema mapping, and then some information about the actual validation. So you do have that as an option as you're submitting data. If you don't want to go back and like listen to the recording or view my slide deck, you're welcome to go and take a look at the rule catalog. And that is also available for all of our cross-feature validations. So here's a cross-feature validation, and there's a rule catalog you can download for it. Okay. So let's start talking about legacy validations. So legacy multiple layer validations, these are all going to start with a 2.1. So if you're using that search function, so you don't have to go through all 45 assignments or so, 2.1 is going to be your legacy multiple layer validations. We have two types. We've got alley to SSAP or road center lines and road center lines. And we also have MSAG to RCL. So comparing an MSAG table to road center lines. For our alley to address points, road center lines, essentially it's going to be checking if an alley record with a concatenated street ESN community and concatenated house address number fields, if it matches at least one address point, then it must also match at least one road center line. And if it matches at least one road center line, then it must match at least one address point. So essentially, it's going to be finding and marking up alley records that are not matching your address points and your road center lines. Because this is marking up alley records, your output for this is going to be in the markup table. Since it's not going to be a spatial markup, it'll be in the markup table class. The other check in alley to SSAP RCL, our address point road center lines, is an optional check. And that's just checking to make sure that our alley records match both an address point and a road center line. We also have the MSAG to RCL. So this is going to be checking that your road center line address ranges are synchronized with MSAG, with your MSAG records. So if a road center line has non-zero to from address values, so they're not equal to 0, they're not null, then there should be a MSAG record that has a matching concatenated street, community, and ESN, and that the address range is within the MSAG range. So it checks for nonconformances, like if there's, say, a road with an address that doesn't match. I think that should be reading. Oh, that's not the right spot. But essentially, if it's not matching those address ranges, it's going to be flagged as a nonconformance. We also have our cross-feature multiple layer validations. So these include a bunch of different ones. We have point-to-line validations. So we're going to be submitting an address point layer as well as a road centerline layer. If they're in the same file geodatabase, you can just submit the same file geodatabase for both layers. You'll need to submit it twice if both address points and road center lines are in the same, because you're going to want to submit it on behalf of the road center lines and on behalf of the site structure address points. This is referred to as a fishbone analysis. I'll explain what we mean by fishbone and how that works after I go over the other cross-feature multiple layer validations. We also have point-to-boundary validations. So these are validations between site structure address points and our boundary layers, which includes emergency service boundaries such as EMS, law, and fire, as well as PSAP. Next up, line to boundary validations, again comparing road center lines and those boundary layers. And then boundary to boundary validations, which includes all three of our emergency service boundaries, EMS, law, and fire, and comparing them to PSAP. So let's take a closer look at each one of these, and I'll explain what the validation is actually looking for. First up, point to line or address points to our road center lines. Essentially, this is checking to make sure your address points are geocoded correctly to road center lines. So we want to make sure that they're in the correct order, that the attributes are matching, and that the address points are on the correct side of the road. An example of a road and address point set that conform to these requirements. We'll go over an example that conforms, and then we'll go over an example that has some issues. So here I have 2nd Street. I've got my road center line. Here are some various address points. And during this validation, what's going to be created are called fishbone lines. So essentially, that's going to take each address point and draw a line to its corresponding geocoded location along the road center line. So for this example, this is kind of what it looks like. And it's geocoded in proportion to where it should be along that road center line. If we're looking at a much larger data set, so this is what it looks like when everything looks good. If I was to look at a much larger data set, this is essentially what it looks like. The reason it's called fishboning is because it should look like fish bones along the spine of a fish. So this is an ideal, like what I would see with that fishbone analysis. And it's essentially just making sure our address points are in the correct spot along those road center lines. Now let's take a look at an example that would result in nonconformances for each one of these points in my description. So here's our new example. We've got Main Street with these addresses, or my address ranges, and we've got a bunch of address points. So looking at our first, actually, let's look at the fishbones that are actually created. So not every one of these points will have a fishbone line created, which is indicative of a non-conforming feature. So the address point is not conforming to some of these requirements in that description field. And so you'll see like the fishbone is not going to be created for them. Let's look at each of these, starting with all address attributes of a point feature match the address attributes of a nearby road. So if a street name is incorrect, or if it's misspelled, as you see in this one here, it's not going to have a fishbone line drawn for it because the validation cannot identify that address point belongs to that road center line. So it won't have a fishbone line drawn. And then that one will be flagged as a nonconformance. Next up, we have point feature address number parity matches road feature for parity for each given side. So we look at both the left side and right side of the road center line. And the parity can be a field within road center lines attributes. It can also be based on those address ranges. So on this example, the left side of the street is odd, the right side of the street is even. And here we want to make sure that the addresses of the address numbers of the address points are matching the parity of the address ranges of the road. So we have one example here, 1707 Main Street is on the even side, but it is not an even address number. So that one would be flagged, even though it has a fishbone drawn for it, it's still going to be flagged as a non-conforming feature because its parity is incorrect. Next up, point feature address number is within the road feature address range for a given side. So the ranges here, we have 1702 to 1708 and 1701 to 1709. So all of our address numbers should be within those ranges. We've got one here, 103 Main Street, that's not within the range, so it's going to be flagged as a non-conforming address point. And then because it's not within that range, it also was not recognized as having a connection to this road center line, so a fishbone line was not drawn for that address point. And lastly, we want to make sure our point feature address numbers are ordered correctly along the road. So if the address points are not ordered correctly, oftentimes the fishbone lines end up crossing each other. So you can see that here with 1704 and 1706 Main Street, they're not in the correct order along Main Street road center line. So our fish bones have crisscrossed. So that's an example of two address points. They're not in the right spot uh, and would be flagged as a nonconformance. So again, here's all of our nonconformances within this example. I'll also point out, similar to our single layer validations, you do have exceptions for cross feature validations, multiple layer validations. So if, for example, 106 or not 106, 1706 and 1704 Main Street, if that is correct in the real world, and we need to mark those as an exception, you should be able to do that within the markup output. And then resubmit with those new exceptions. So moving on to our next set of validations, we have point to boundary validations. We check a couple things with point to boundary. We want to make sure that our address points are within PSAP boundaries and our address points are within the emergency service boundaries, so EMS, fire, and law. So non-conformances here, I've got an example of a PSAP with address points. My one non-conforming point is outside of that boundary, and so it's being flagged as a non-conforming object. Next up, we have points should be within emergency service boundaries. So if this is my fire boundary, for example, my one address point that is not inside the boundary is going to be flagged as a non-conforming object. I will say my examples are very conceptual in nature and not a large data set. I just kind of want to make sure that you understand what some of these items are looking for. So in my fishbone example, the address point to road centerline cross feature validation, I only have Main Street. But if 103 Main Street does match another road centerline feature on the other side of the PSAP, it will draw a longer fishbone line. But it might, if it crosses any other fishbone lines, it might still be flagged as a non-conforming object. My town is very small. I only have one Main Street. That's the only street. So in my conceptual example. Moving on, we want to cover road center lines to boundaries. So when we're looking at road center lines, we want to make sure that they're splitting at our boundaries. So at the PSAP or an emergency service boundary. If this is my PSAP boundary, for example, and I've got two sets of road center lines, the upper one is going to be conforming because it's split at that boundary. The lower one is going to be my non-conformance because it is not split at that boundary. It's crossing the boundary and is therefore going to be flagged as a non-conformance. So just be aware of that. If you do have some of your road center lines that cross outside of your PSAP or outside of your emergency service boundaries, it'll flag those as non-conformances. And then lastly, we have our boundary to boundary validations. These validations are essentially checking to ensure that there are no overlaps, gaps, or extended coverage between our PSAP boundary and our emergency service boundary features. So if I've got my PSAP boundary and I have my ESB, which could be my EMS boundary, could be my fire, or it could be my law boundary, I want to make sure that there's no gaps, there's no overlaps, and there's no extended coverage with my PSAP boundary. So non-conformances in this one, we've got an overlap. So if there's an overlap and we want to make sure that those are flagged as non-conforming. If there's a gap in coverage, that's going to be flagged as non-conforming. And again, if there's a extended coverage, so if the ESB boundary goes beyond the PSAP boundary, that's going to be flagged as a non-conformance. There was a question about when snapping to a boundary. Does it need to be snapped to a vertex or snapped to an edge? It just needs to be snapped to a boundary edge. I think that was in regards to road center line to boundary. So that was a quick overview of the checks, the validations that you'll see within those cross-feature validations. With very general examples of ways that your data could potentially be a non-conformance for each of those validations. Next, I want to talk about change detection.
Actually, Carolyn, would you mind if we just pause for just a moment?
Yep.
I'm thinking there may be some more lingering questions out there before we jump into change detection. So change detection, again, is that submitting your aggregated data up to the state. But yeah, are there any questions on what we've covered so far with the cross-feature validations? I believe we've addressed most that have come through the chat. Again, the first question was about the really long fishbone line if your data matches across the county, and yeah, but it'll be flagged as a non-conformance. And then the other question about snapping the road center line to the boundary edge. But oh, looks like Jonathan, you did just reply to Justin's question about how to manage exceptions in the case of where where a PSAP or county is maintaining their data. Let me just go back to that question because I'm sure it's one that maybe more people have if you didn't read the chat. So yeah, Justin's question was about what's the state's position on how to go about fixing non-conformances. In several counties, addresses have been assigned with varying addressing intervals based on who's assigned the addresses over the years. And many counties had addresses assigned just haphazardly in a chronological order down the road. And so changing somebody's address is a big to-do. And so Jonathan's reply to that is that, let's see. Yeah, so our tools here at One Spatial will identify any major issues you need to correct. And then you'll need to decide whether or not the change needs to be made. And if not, definitely mark an exception to that rule. So yeah, you have the ability to mark this as exceptions, and it sounds like Jonathan's all for them. Jonathan, I don't know if you want to expand on anything there.
I'm good unless Justin had any other questions.
Cool. All right. Are there any other questions about the first part? We may start to get into this just a little bit and maybe try to take a 5-minute break at the top of the hour. So, anybody can grab a coffee or anything that they might need then. Does that sound okay, Carolyn? We'll break in maybe 15 minutes for 5 minutes.
That sounds good.
All right. Thank you. Sounds good. Sounds like we can continue then. Thank you.
Yeah. All right. So change detection. This is actually where you're going to be running your data through what we call change detection. And ultimately, it's going to be submitting that data to the central database. So going back to this diagram from the beginning, we've been doing data validation, and that includes those cross-feature validations. Now we're going to be looking at that change detection and data submission. So again, once that data passes those validations, you can then start submitting data to the state through change detection. With change detection, it's going to take that current submission and compare it to your previous submission. So if this is your very first time going through change detection, everything being submitted is just going to be compared to anything that's currently sitting in the database. If there's nothing sitting in the database, that very first submission is going to be just all changes because it's all new. But then after that first submission, it will be comparing a new submission to change detection to whatever's sitting in that central state repository, that central state database. Now, the reason it's going to be checking just for changes is because we're not going to upload all of the data that you submitted to the state repository. We're going to only upload the changes that have been identified and make those changes to the state repository. So that will cut down on how long it takes to actually commit that data to the repository, to the database. And then only those changes are going to be used to update that database for Arkansas. So similar to how we had data prep for our data validations, we do have some data prep we need to do for our change detection. And that includes making sure that we have a globally unique ID populated, that our data has already been run through essential geometry assignments first. So if you're running address point change detection, you want to make sure you run that data through essential geometry and that it passes those validations within essential geometry. And for change detection right now, we do want to make sure that you reproject your data into WGS84. That is what the database is going to be using. And we want, when we compare the submission to what's sitting in the database, we want to make sure they're in the same projection. So for right now, we do want to make sure that you reproject your data into WGS 1984. And then once again, we want to make sure that our file geodatabases are compressed into zip files prior to submitting to a change detection assignment. Now, once we get into the portal, the workflow is very similar to our other validations. We still have that upload data, configure mapping, process submission, and submission results. And we do have assignments for each submitted data layer. So address points, road center lines, EMS boundary, fire boundary, law boundary, and PSAT boundary. You still will be doing some configure mapping. Essentially, you want to map as many of your attributes as possible. And then we have process submission. So process submission, there's this new thing that you'll see, and it's called a safety gate. And this safety gate is just making sure that during the submission, your data conforms to whatever has been set up in that safety gate. Right now, we just have one safety gate, and that is checking your NINA globally unique ID. We want to make sure that it is indeed unique and that it is populated. So you'll see a safety gate, and I'll explain when we actually are looking at process submission, what that looks like and what you need to do to pass that safety gate. There's also pre-processing within our process submissions. You've probably seen some of those in the other validations. You have the change detection session itself. And then if you do pass the safety gate, at the very end of the change detection is where it will write the data to the central database. And finally, our submission results. So previously we had only been downloading spatial report as an output. Now with change detection, you can see the proposals, so the changes that were proposed and applied to the database if it was successful with committing that submission to the database. And then there's also session metadata, and this is going to be some information about the different changes that were within that proposal, the proposal's output. And then, of course, we also have our submission report. So similar to other validations, if you want to download that PDF and save it as a copy of how the data went through, you can still download that submission report. So this change detection assignments that you'll see still follows this very general workflow that you should be familiar with, but there are some key aspects of this process submission that I'd like to cover in detail before I show a submission to a change detection assignment. And that's really, I really want to focus on safety gates because I know that's new. So with a safety gate, we have just the one that is checking your NINA Global Unique ID. There's two parts to it. It's checking that your NGUID is populated, and it's also going to be checking that your NGUID is unique. There's also some pre-processing tasks there within the session. We set different session parameters to make sure that when the session's running, it's going to be submitted to the correct part of the database, that it's running the, it's running the correct class through those validations. And then there's some additional pre-process actions that we'll do to make sure that the data is clean before running it through a change detection. Now back to these safety gates. If you pass your safety gate, you do have to scroll down to the bottom and hit resume, because what happens is during that safety gate, it pauses the submission. So if the submission is paused, it needs you to go back in and either hit resume and change detection will proceed. And with that, it'll write those changes to the database. But if the safety gates are not satisfied, so let's say I have a data set that doesn't have a unique ID that is unique, like I'm repeating unique IDs within it. That would be one way that my safety gate would not be passed. What you need to do is scroll down to the bottom of the screen, and instead of hitting resume, you'll hit acknowledge, and that will just finish the submission. You won't go through change detection. You'll need to go and address that issue of, in this case, we only have the NGUID safety gate. So you'd need to go and make sure that your safety gates or your NGUID is unique and populated. Now let's say I have unique and populated NGUIDs. I pass my safety gate and change detection proceeds. Well, what's happening in change detection? There's a series of steps within change detection itself. It's a series of different processes that are going to identify how our data differs between a current submission and a previous submission. So for submission to these change detections, our portal is going to compare our submitted data to data that currently exists in the database. I'm going to use road centerlines as an example, but very similar methods happen for address points. Similar methods happen for our polygon layers, our boundaries. So for our linear and polygon layers, we do build topology just to make sure that any of the submitted data, it just snaps to the previous data, the data that's within the database. The portal would then identify our perfect spatial matches. So from our submitted data, these are the road center lines that perfectly match what's currently sitting in the database. It's not looking at attributes at the moment. It's just going to be looking at the spatial matches. From those spatial matches, those are kind of set aside, and then the other features that have been added from the submitted road centerline, those are identified, and those are flagged as additions. So if any new data has been added, that's going to be flagged as an addition. If any data has been removed, so from my submitted road centerline, if say a development has deleted a road and that road is no longer there, that would be identified as a deletion. So here, for example, my second from the top road is no longer in my submitted data. So that's going to be flagged as a deletion and it'll be removed. And then there's attribute or scalar changes that will be flagged. So from those perfect spatial matches, the attributes will be compared and those will be flagged as scalar changes. So here I have 2 streets. One's been changed from 3 RD to 3rd. So that's considered an attribute change and will be flagged as such. And then for road center lines, we do identify any geometry changes. So if the road center line is a road reshape, for example, that's flagged as a geometry change, and that's only done for road center lines. So throughout this process, we will create, the portal will create those features within that proposals class, those changes, to identify the features that have been flagged as adds, deletes, or scalar changes. So when we do look at our output results, I mentioned there's 2 output results in addition to the submission report. So there's session metadata and there's proposals. So the session metadata is essentially a table that describes detected changes, including the number of features added, deleted, rejected, and updated. So you'll see per layer, if you're doing multiple layers, ours are all separated out for Arkansas. So you'll see it like per layer within that session metadata. If there's new features added, it'll have a count of those new features added. If there's features deleted, it'll have a count of that. And if there's features that have been updated or rejected, those will also be counted. We also have our proposals output. So these proposals are not necessarily proposals, but they're more of changes that have been applied to the database. So a couple different columns here I want to make note of. We have type, so it's going to identify if it was an add, a delete, a match, like a perfect match, a scalar update, or if it was rejected. We also have different changes. So if it was an address change, it'll be identified as address change within that column. There's a couple other changes if it's a geometry change, name change, date change, any of those. So these are different ones that you may see within these as columns within our proposal. We also have base ID and update ID. So base ID is going to be the NGO ID that's within the database. Update ID is going to be the ID coming from our submitted data. So these are all additions. So there wasn't a base ID. So base ID is null. And update ID is going to be the ID that's associated with that data within the database after this change detection has been committed or has been run and the changes have been committed. Next up, if there's any additional notes, those are going to be identified here in the notes section. Oftentimes it's not used, but I just want to make sure that you're aware of what could potentially be in that notes. This is a good time for a pause. If we want to take a quick break, and then when we come back, I'll actually run a address point data set through change detection so you can see in real time what it looks like when I hit that safety gate, and we can take a look at the output. All right, so Sarah, do you want, how long of a break do you want?
Thank you, Caroline. So yeah, let's just real quick run through the questions that have come in case anybody didn't see the chat box, but there's been a couple. So There's a question about the proposals in general. Casey was wondering if that means the data supplier needs to go and improve the changes before they are actually pushed to the statewide database. And nope, that happens automatically in the system. It takes care of that. We were just letting you know what the system does while it's going through this process. So takes those proposals and it'll apply those changes. And like Carolyn mentioned, you can download a report of what has changed after the submission runs through. So you can get these output results that are shown here on your screen to review after it's completed. And let's see, Jennifer asked about catching any NGUID, so any unique ID that was accidentally changed. And that is a really great question. So what it's going to do during the change detection process is essentially it's going to remove the old record and add in the new record with the new unique ID. But if that new unique ID is duplicated anywhere in that same data set, it'll be caught. The submission will be rejected because you need to have a truly unique ID in order for it to be accepted. And then after that change detection process, you can come and see the summary statistics and the output results and kind of see, what changed. Did I intend to have 10 features completely change, and maybe you look into see why and what changed. So I hope that makes sense. And if there aren't any other questions at this point, then yeah, let's take a quick 5-minute break, and we'll start up, or maybe 5-6 minutes. We won't start out right at the 5-minute mark. So yeah, go ahead and take a quick break, and we'll see you back in a few minutes. All right, we have hit our 5 minutes. Maybe give 1 more minute for people to come back, but yeah, Carolyn, if you want to reshare your screen.
All right. So, we were talking about change detection. So I just want to show one data gateway again. Let me bring over that screen. So I'm going to sign back in. So you'll see that you probably will have a lot more assignments as the cross-feature validations are rolled out, as well as the change detection assignments are rolled out. So again, you can always use the arrows at the top right to scroll through, but you can see I've got 4 pages now. So another option is using this filter assignments. I'm just going to enter in change so I can get to a change detection. And I'm just going to choose address points. So again, I've got some address points that have run through. I'm going to hit, again, I just want to point out rule catalog. We do have that available. This is what that rule catalog looks like for change detection. And essentially, it's just going to say identify and apply adds, deletes, and identify perfect spatial matches, and check for scalar changes. So here, I'm going to start a new submission. I'm going to grab some data to upload. I'm just going to grab, this is actually an empty schema, so it runs super quick. But I want to show you on these configure mapping stages, very similar to the NINA attribute validations. You'll see that once it uploads, there we go. You'll see the schema mapping is very similar. So if I expand this out, you'll see all of the, remember, target mapping is going to be the target schema that lives inside the portal. So target would typically be our NINA schema, as well as we've added in some of the Arkansas schema as well. So target attributes, you'll see all those listed here. And again, if you're more comfortable mapping your own data, so if I switch that, now my source is on my left, and I'm going to be mapping to my target class. So here I would choose APF for my address points, expand those out, and then I can choose and map these. Now again, this is from a saved mapping. So once you get to this point, and if you don't see any of this mapping done, go ahead and map it out here, and then scroll up to the top, hit Manage Schema Mappings, and save your mapping. So maybe this is change detection for APF. So now I have a saved mapping. I can reuse this the next time I run a submission through. You do have the ability to set those saved mappings up prior to running a submission. Again, when you're in an assignment, go to the Saved Mappings tab, and you can set that up before even starting an assignment. Now I've unmapped source data because this file geodatabase has the other layers in it. So it has road center lines, my PSAP boundary, etc. So that's all right if I have unmapped source data, but I do see all my target classes and attributes are mapped. So I should be good to continue on. If you don't have all of your target classes and attributes mapped, that's okay. You should still be able to continue, but please make sure, where is it? Nina Global Unique ID, site NGUID. I do have my NGUID mapped. That's going to be the most important one because it has a safety gate it has to pass. So scrolling back down here, I'm going to hit continue. So this is going to trigger the process submission. So you'll see once it gets started, there we go. Again, this is an empty FileGeo database, so I don't have any features I'm actually passing through at the moment, but you can see it's hit this safety gate. So my current status is paused. It's only processed 4 of the 20 tasks. And at this point, it just says pause. Now I did pass. I didn't have any features, so of course it passed. But at this point, I need to scroll down. And if the submission passes that safety gate, I should see resume at the bottom right. So I just have to click resume and it will start the process up. So the submission is going to start going through those different pre-processing actions. And then it will go through the rest of the change detection. So you'll see identify spatial matches. It'll compare this submission to what's sitting in the database. It'll identify adds and deletes. It then prepares for a proposal application. So essentially, this is just going to remove those perfect matches. If there's a perfect match, you don't need to update that in the database. So it doesn't want to spend that time updating the database with perfect matches. So those are just removed. We're only going to be applying deletes, adds, and those scalar changes. And that's what happens later on. Apply deletes, apply adds, apply scalar changes, and then populate those session classes. So the session markup that you can download, export proposals, and then the export to system classes. So essentially those sessions, updating the metadata sessions. And then the final commit, this is going to be committing any of those changes that have been identified to our database. So since my submission has been processed, I do need to hit continue to move on to my submission results. Similar to our other data validation assignments, I have my metadata here with that reference ID. So if you need to use that to refer to a specific submission, you have a submission reference ID you can copy. Submission data. So again, I mentioned a session metadata, address proposal, and the original data that I submitted. Just going to hit download on those. And then I have all the results from that change detection. So with that, I have it's called a proposal, but it's essentially those changes that would have gone through, as well as the session metadata. In this demo, I don't want to really push anything to the database at the moment, so that's why I submitted an empty FileGeo database. But I'm just going to hit close on that. So now I can see it in my submissions. There we go. This one I just ran. And then I can take a look at that schema within the address proposal output and the session metadata output. So I can at least show you what that schema looks like in QGIS. I don't crash QGIS again. So let me add those in. In my downloads, address proposal, we'll go ahead and add that in. Oh, it didn't create any because it's empty. Ooh, that wasn't a good one to show. Let me see if I can grab from a previous. But essentially what I will see is that if there were address changes, those would be populated. If there are any geometry changes, especially for our road center lines, there might be a geometry change. If there's a name change, those are all identified here. And again, that type is also going to be very helpful. So it actually shows you this is an addition, this is a deletion, meaning it no longer exists in your proposed submission. And you'll see that within that address proposal. Proposal is a bit of a misnomer, but that's how our data stores has been referred to, a legacy referred name. I do want to leave you with some tips, tricks, and lessons learned from some other folks that have conducted change detection as well as exception handling, and they've been running the cross-feature validations. Similar to last time, highly encourage you running those essential checks first. So the essential validations, running the data through the geometry validations and the network validations if you have road center lines, and then clean up that data based on the markup results from those validations. So for example, if you have duplicate address points, make sure that those are either marked as an exception or have that understanding of like that is going to be a non-conforming object because it's a stacked address point, for example. But anything else that you can clean up, try to clean that up prior to running these more advanced validations. Feel free to resubmit data to these validations. So after you clean them up, resubmit them just to double check that you are now satisfying those conditions, those requirements by each of the validations. And then once you have a good set of data, go ahead and start running the advanced validations. If it's a cross-feature validation you want to run, or if it's the change detection. Let's see. We also have oops. There we go. Those rule catalogs, any information for assignments, that's going to be very helpful with identifying what you might need for these different validations, as well as what sort of checks are actually happening in said validations. I'll show you with our cross-feature validation. Let me just type in cross to get to one. Our fishbone validation, for example, has a really good rule catalog. So if we take a look at this, it does explain those fishbone lines with an example. It does tell you exactly what schema you need for that site structure address point to road center lines. Especially for some of these cross-feature validations that concatenate like address number attributes, or it concatenates like the community, ESN, and street name. Those are going to be very important for you to ensure that you map during the schema mapping step. Otherwise, it could lead to non-conformances in the data, or even potentially errors, and the session could error out, or the submission could error out. So just be aware, these rule catalogs, we've spent a lot of time creating them so that they really do help you as you're submitting your data through the portal. It also will go over any sort of pre-processing if there's an action or a task that you're unfamiliar with, like, what does this particularly mean? We do have descriptions of each of those pre-processing actions for our cross-feature validations, as well as a description of the different checks within that particular validation. So I mentioned essentially like the main part of the fishbone analysis. There's additional details that I kind of left out, but it essentially is I combine them all into one, but checking that our fishbone lines correlating to address points are ordered along the road center line, checking are they crisscrossing one another, and if those site structure address points are mapped to multiple road center lines. That's another way it could potentially be a non-conformance within this validation. So I definitely highly recommend checking out these rule catalogs. They provide a lot of information about our various cross-feature validations, and they're a really good resource as you are starting to submit data to these different assignments in the portal. Oops. Also, save your schema mapping. So enabling or saving a schema mapping is going to enable you to be able to reuse that schema mapping. If you've submitted to a NINA attribute validation, you've probably noticed that there's a lot of attributes for the NINA layers. You don't want to have to redo that schema mapping every time you submit data. So saving your mapping is going to help save time later on. So the first time it might be a bit of a headache, making sure all of your attributes are mapped correctly. But once you have that saved, you can reuse it later on, and you won't have to remap every time you submit data to a particular assignment. Speaking of saving your mapping, you can also copy mapping. So if I have a saved schema mapping from my attribute validations, I can actually copy it to, say, one of my cross-feature validations. Or I could copy from a NINA attribute validation to a change detection session. So within the assignment itself, you'll see saved mappings, and you can create a new mapping, and you can do that configure mapping step from scratch. You can also copy a mapping. So if there's already a mapping that is used elsewhere, these essential geometry checks are basically just using unique ID and geometry, so it might not be very helpful. But if I find like a NINA attribute, so maybe the one for Benton County, or even this change detection APF or address points, those might be more beneficial for me to use for a different validation. So once I find a mapping I want to use, I can then say, use it for, I'm going to use this one for my address NINA template. And then we'll just give it another name. So this was SAP to RCL addresses. I'm going to copy that. And then here I can re-upload some sample data for those, but because I'm copying that mapping, it should have these address points sort of saved. So you can go through this. You can also save and copy those schema mappings. And again, if I go back up to my assignment for one spatial tester, if you change your schema, or if the county that you live in decides to update their schema and these saved mappings are no longer useful, you can save up to 10 per assignment. But if you reach 10, you're like, I'm ready for a new one. You do always have these delete buttons. You can also edit the saved schema mappings outside of a submission. So I touched on this in the last training, but I want to bring it back up because it can, now that you're getting into these advanced validations, it can be very helpful to copy these saved mappings. Or if you just want to spend an hour in an afternoon to like create your schema mapping before even submitting data, it can be very helpful to go ahead and have that schema mapping ready before you even run a submission. So you can go ahead and we'll have the sample mapping, the sample mapping put up, and then do the configure mapping. And I think that is my, oh, I also just want to show with our Arkansas schedule, you should have access already to those essential geometry validations, the essential network validations, NINA attribute validations, as well as gap and overlap validations for boundaries. So you now should have access. I believe Sarah and the rest of our team at One Spatial have been working on updating the assignments so that you have access to all those cross-feature validations, all those change detection validations. And then for those of the state office, so like if you're in the state office, if you're going to be running the statewide validations, those should also be up. I believe we'll have a different training specifically for your office to kind of cover those cross jurisdictional validations. And
Yes.
with that, I think I do have, no, that's not going to work. Yeah, I believe that takes us to the end. We do still have some time, so if there are any additional questions, I haven't seen anything else come through the chat. Let me double check. But if you have any questions, we're more than happy to answer those now. We'll open the floor.
Yeah, thank you so much, Carolyn. So as a reminder, I know she went through it already, but before you submit your data up to the state, it's a good idea to get those essential geometry issues fixed. So I would definitely recommend running essential geometry and essential network at a minimum before you submit your data up. And also before you submit, your data will need to be in WGS 84. Or else it'll be rejected. It also needs to have that NINA globally unique ID on every single feature. We are looking into an update, and we will provide an update to y'all when it's ready. But yeah, we're looking into being able to reproject data sets on the fly when you're submitting up to the state, for those of you who may be maintaining in state plane or NAT 83 as examples. But yeah, if your data is already in WGS 84, then you're good to go. If it's not, for right now, in the interim, in the next few weeks or so, you'll need to reproject before submitting it up to the state. But yeah, I'm going to, I provided it a little bit earlier, but as a reminder, I'm going to link your portal here in the chat box. So yeah, just make sure to bookmark it, use it, get your data in the system, start running those essential and attribute validations, your boundary gaps and overlaps, and yeah, let us know if you have any questions. And it looks like Casey has one. So yeah, the update will it also include the ability to carry over schema mapping if the layer name changes. Yes, Casey, we're looking into that right now, and we'll provide an update to that. We're hoping to get you an answer on that even before we get out the update for the reprojection. So yeah, we'll let everybody know about the schema mapping. So what we ran across was when you are trying to, or when you're saving your schema mapping, if your layer name changes, say you append the date to the layer name at the end of the layer, that you'll need to remap because it's recognizing it as a brand new feature. So we're looking into that, and we'll provide a workaround or an update to the system so that it'll recognize those as a save schema if the layer name changes. So yeah, and another question. All right, are you all still working on being able to take a REST endpoint? Oh, yes. So we are still working on that. We will have an update. I think it's coming out this quarter, if not next quarter, but we'll provide an update on the timing for that. I know our development team is actively working on being able to incorporate REST endpoints. So that's when you're uploading data, so you don't have to do the zipped file geodatabase. You should be able to just throw your REST endpoint link in there and then run validations on something that's already, a feature service as an example. So yes, great question. That is coming down the pike, and still really hoping to get that out this quarter. All right. Are there any access issues? Has anybody had issues logging into the system? Does everybody have an account that needs to have an account? Again, I threw the link in the chat box. Your login is your email address and the password that you set the first time you activated. So if you need a password reset, let us know. Type a message here in the box and we can send you a password reset link. If you don't have an account and need one, reach out. Or if you have any other issues, of course. So yeah, after today's training, if you have, just general login questions, those can be directed to the state. And yeah, they'll forward any issues to us if they're unable to resolve the login issues. All right, Carolyn, do you want to mention the training survey?
Yeah. So we do have a training survey. I've just popped the link into the chat. We do appreciate your time from today. And again, if you have any questions, you can let us know in the chat now. Especially if you had any issues logging into the portal prior to this training or even during this training. Additional questions regarding submissions to any of the validations can be sent to Jonathan Duran. He does have our information at One Spatial, so if there's anything he needs to pass our way, he's able to do that as well. And just thank you again for your time. We really appreciate it, and we hope you are able to begin submitting some data.
All right, thank you so much, everybody, for joining today. We will send you, or at least the state, and they can disperse it, a copy of the recording and the slide deck and some rule catalogs and whatnot. So yeah, thank you so much for your time today, and go have a great lunch and rest of your day. Thanks, everybody.